Okay, hello, welcome back. This next section is on slope, basically. Slope is, believe it or not, one of the most important parts of calculus. And you've dealt with slope a lot, and there's a, we didn't do it for fun. It's applicable to everything we're doing now. So slope, what is it about slope that we are interested in? Well, you know about the slope of a line, right? So you have a line here, and maybe you're given some point x1, comma y1, and maybe some other point x2, comma y2, right? So you have maybe some point x1, y1, some other point x2, y2, and to find the slope which describes the entire line forever and ever, you go y2 minus y1 over x2 minus x1. And what is that? That's the change in y, which we put delta y all over some change in x, which we write delta x. Okay. There's four kinds of slopes, basically. The positive slope, so m greater than 0. There's the negative slope, so m less than 0. There's the zero slope, so if you just have a horizontal line. And then there's the undefined slope, which is what happens when you have a vertical line. Okay, what we're trying to do in calculus is to extend this idea of slope to more complicated curves, right? So we'll have maybe something which has a bunch of bumps in it, or something like this, I don't know. Okay. And at any point, we want to kind of know the quote-unquote slope. Okay. So for example, here, if I attached what they call a tangent line to the graph, we would see the slope is positive, which kind of tells us at that point the graph is going up. And maybe over here, we could attach a slope there, and there the slope is negative, right? We could put a slope here. What's the slope there? Well, the slope is 0. And that's important because you kind of have a maximum there. It's the top of the hill. So if we had a formula that would tell us kind of what the slope is at a particular point, we could look for where that slope is equal to 0, and then we would know kind of these points here. And that gives you characteristics that allow you to kind of graph the thing. And not only that, it'll allow you to maximize and minimize functions. And if you're working with in business and you want to maximize profit, that would be something that you would be highly interested in, right? Okay, so the point of the slope stuff, we're going to generalize it here in calculus to more complicated scenarios. Okay, so we need to have this down pat. And so here we go. So where do you usually see these slope things? You see them in equations of lines. So the first and probably most important equation of a line that you have is the point slope form. Okay, so if somebody gives you a point and a slope, all you have to do is plop it into this formula, and you'll have an equation of a line. Okay, so an example, somebody gives you, maybe even in a harder example, right? Somebody gives you 2 points, and they want the equation of a line that goes through those 2 points. So how do I do that? Well, first you get your slope. You need a slope. So y2 minus y1 all over x2 minus x1. What is that? 9 all over 3. So that's equal to 3. And then we plop stuff. We have 2 points. We only need one of them. I'll take the 1, 7, the one without the negative. So I have y minus 7. So this is my x1, this is my y1, equals 3, the slope, times x minus 1. Okay, and then I just solve that for the equation I want. So y minus 7, I'm going to distribute this 3x minus 3. So y is 3x negative 3 plus 7 is plus 4. And there's my equation. Okay, okay. Application type problems. So this example is about apartment rental, and they want you to find a linear function to describe the scenario. So in this scenario, when they charge a rent of $780, they found that they had 50 people renting the apartment. So a rent of $780 gives you 50 people, 50 renters. Okay. If you charge a rent of $825, it goes down. People aren't willing to fork over that much money, right? It goes down by 3 people. So you can create an equation which describes the number of tenants you'll have as a function of the amount of money you charge for rent. And the book wants, or the problem in the book, and the problem that I'm working with wants you to find a linear function just to describe this. Find basically the equation of a line, which is what is weird is they want you to use x for the rent and no, strike that. P for people and X for rent. And they want it as a function X of P. Okay, so where X is the, I guess maybe I got that wrong. It's X is the number of people. And P is, so that's why I wanted to go through this problem. It's a little confusing. P, they wanted that to be the rent. Maybe they mean it's price, or I'm calling P would make more sense for people, but oh well, just go with what they say. In that regards, that means that P is the independent variable, and then X will be the dependent variable, right? So the ordered pairs will be PX, and in this setting, our ordered pairs will be $780 for rent, gives you 50 people, and then the other ordered pair is $825, gives you 43 people, okay? Okay, so that's just from the given information. So we want to make our equation. So what do we need? We need a slope. Okay, so 43 minus 50 is negative 7. And then 825 minus 780 is 45, I believe. Oops, whoops, 43. It's 47 in the book, sorry. It's 47. Screw that up. Okay, so 47 minus 50 is negative 3, and then we can reduce that to negative 1 all over 15. Okay, so basically as a rate of change, this would mean the rent goes down, or the number of people that want to rent inside of your apartment complex goes down by 1 for every additional $15 that you charge. Okay, so we can do our formula now. The formula look a little weird because we're using the x as our y. Okay, so it'll be x minus x1 equals m times p minus p1. Okay. So in our case, let's use the 780, 50. So x minus 50 equals negative 1/15 times p minus 780. And then we just simplify that thing and we'll be good to go. That's 52. Add 50 to both sides and you get your function. Okay. Okay. Right. So okay. Let's move on to graphing. So, and looking at some of the other forms of the equation of lines. So, graphing, and we have the slope-intercept form, okay, which we've already been using, but now we're actually going to invoke it, slope, intercept. So that's where you have y equals m times x plus b. Okay, so the m thing is the slope, and the y thing is your y-intercept. Okay, so at 0, comma b. Okay, let's look at an example. So number 30, or let's just keep it as an example. Right. So y is 1/3 x minus 1. What is the slope? So the slope is whatever's in front of x, which is 1/3. And then the y-intercept is the leftover part without the variable. Right? So that would be 0, -1. And then we can graph it just using those two things. So we start at the y-intercept, 0, -1, so start here. And then we use the slope to get the next point. So the slope says go up 1 and then right 3. Okay, so go up 1 and then right 1, 2, 3, and that'll be our second point. All we really need is 2 points to graph the thing. So connect the dots, and we got it. Okay. Okay, another form, standard form. And this is our final form. You'll have ax plus by equals c, or you could write plus c. Either way is good. So an example, we have x plus 2y plus 6 is 0, and they want us to plot the thing. Okay. What I usually like to do is just rewrite it, moving the constant to the right-hand side. And then to plot it, plot this form, generally you'll do the x and y intercepts. Okay, so you do a t-table. For the x-intercept, you let y be 0. For the y-intercept, you let x be 0. Okay? So when y is 0, x will be -6. And then when x is 0, y will be -3. And you can use those 2 points to graph it. Okay? So there's -6. There's -3. Connect the dots, and you are good to go. Okay. Okay. Plotting horizontal and vertical lines. So for a horizontal line, that's when y equals something, right? So first the horizontal, y equals, let's say, b. Secondly, then for the vertical, you'll have x equals something, right? So x equals a, let's say. So let's maybe look at some examples. They always try to trick you by writing maybe something like 2y equals 6. You have to put it in the form y equals something. So divide both sides by 2, y equals 3. And that will be horizontal line that goes through 3 on the y-axis. Okay, so it would be this guy here. One way that I kind of try to help myself remember it is by doing a table. And this equation means y is always 3, and x can be anything you want. So 0, 1, 2. And then you can plot those points, and you're going to get a horizontal line. Okay, so 0, 3, 1, 3, and then 2, 3. And you can do the same thing with the vertical lines. So another example. And let's make it so they try to trick you, right? So 2x minus 6 equals 8, right? What is this? It's 2x equals 14, and then x equals 7, right? So on the t-table here, x will always be 7, no matter what y is. Okay, so we can plot that using that table. So 7, 0 is here, 7, 1 is here, 7, 2 is here, and if you connect those dots, you got a vertical line. Okay. So hopefully you've seen that before in your previous classes. Let's look at WebAssign and see what you're up against there. I just got my first video up. Oops, that's Facebook. Don't want to show that. Let me scroll on up here to home, and then 1.2. Let's get to Facebook. I don't need to see that. Expand all. Okay, so what are we looking at? Find the equation of the line given a point and a slope. Okay, we did that. Find the equation of a line. When the slope is undefined, it's a vertical line, okay, and it's going through the point 8,7. So you just draw a vertical line through 8,7. This graphing stuff can be a little tricky sometimes. Make sure you're using the double-headed arrow. I had some students try to use the double dot, and that won't work. Even if you get it the line in the right place, so if you get it vertically through that point, it'll mark it wrong. You have to use the double-headed arrow. Okay. What else? And the slope is 8. The intercept is 0, -8. Okay, so we can handle that. Graph the line. Point. Write an equation through the point. Okay, perpendicular and parallel stuff. So maybe we should do that real quick. Get this guy over here, and their point is -9, 6. The line is x plus y equals 9. Write an equation through the line, equation of the line through the point parallel to the given line. Okay, so to find a line that's parallel to this line, we need to know the slope of this line, right? So put it into slope-intercept form. So y is -x plus 9. So its slope is -1. So a line that is parallel to that line, but through this given point, well, how do I do that? Well, you're going to have to go back to your point-slope form. You use the slope from the given line and this new point. So it will be y minus -9 equals -1 times x minus 1. So you have y plus 9 equals -x plus 1. I just distributed. And then you'll have y equals -x minus 8, unless I did some math wrong. Okay. Okay, so that's one type of problem there. If you need the line that's perpendicular to it, which I'm sure they ask, what you need is the negative reciprocal of the original slope. Okay, so if the original slope was 2/3, the slope of the line that's perpendicular to it will be -3/2. So you negate it and flip it, right? So if your slope is given as -5, the reciprocal slope, the negative reciprocal of that for the perpendicular line will be 1 all over -5 negative. So it would be 1 over 5. Let's do another one. What the slope is -1/7. Okay. Then the slope of the perpendicular line will be 7. Okay. So in our case, the slope was -1. Then the slope of the perpendicular line will be the opposite sign, so +1, and then flip it, that'll just be 1 over 1, which is 1. Okay. At the end of the day, if you multiply these two together, you have to get -1 out. So look, if you multiply m times m perpendicular, you get -1/7 times 7, which will equal -1. And that's another way you could check it. So our m times m, and that thing I'm drawing there is an upside down t. That just means perpendicular. So the slope m times the slope that's perpendicular, that'll be -1 times 1, which is -1, which means they're perpendicular. Okay, so this new line, we want it to go through the point -9, 6. And we want it to be perpendicular, so its slope has to be 1. Okay, and then we just go back to our equation, y minus y1 equals m times x minus x1. Fill in the blanks. Okay, and then solve for y, if they ask that. You might be able to just type it in that way, but I always solve for y. What is that, 15? Okay, let's see what else they got. So a little harder one there with some fractions, identifying slopes, and an application. Okay, so I think we're good here. I'll cut the video and I'll see you next time.